Morning, Automate 2024. And hello, Intrinsic team. I can see a couple of you here in the audience. My name's Wendy Tan White. I'm the CEO of Intrinsic. We're a robotics and AI software platform, and we're a solely owned subsidiary of Alphabet that also has our big sister company, Google, as part of the group. We actually came out of Google X 3 years ago into our own separate company. And actually, we've been out there building products, really hopefully for you guys to use today. I'm going to be covering what's really a hot topic, which is how do you actually crystallize the value of AI today, but also in the future? But first, I'd just love to play maybe a little game with you, maybe warm up for the first thing in the morning. There's been a lot of big headlines recently about AI and how it's going to change automation and manufacturing. But maybe let me start here. The AI revolution is coming, but not as fast as some people think. How many of you are kind of in that camp? You feel like you're more in that sort of camp? OK, a few, actually. OK, not too many skeptics in here. OK. The fusion of robotics, AI, AR, VR, a 2024 revolution in manufacturing. How many of you think that's where we are today? OK, optimistic, more optimistic. What about this headline? This is the real headline. AI-driven big factory sparks revolution in versatile humanoid robot creation. A lot of random buzzwords. Anybody in that sort of camp? OK. What about this headline? Many of you must know this one. The fourth industrial revolution is here. Are you ready? How many of you have heard of that? OK. I'd have thought you'd heard of that, because this headline came from 2011. OK? 13 years ago. So were you ready then? Are you ready now for the fourth industrial revolution? You know, we're not there fully yet. We're not at fully flexible production, smart, intelligent factories. But we are making big steps towards it. However, we do believe AI is going to help bridge this gap. Anybody know this curve? Yeah? OK. It's called the Gartner hype curve. Gartner publishes this every year, has done for maybe 25 years now. It's called the Gartner hype curve because, as you can see, when a new tech comes in, so let's say generative AI, it triggers a lot of excitement at the beginning. And eventually what happens is you get into what we would call the peak of inflated expectations, or hype, the hype point. Usually then what happens is the expectations aren't met, and everybody goes into something called a trough of disillusionment. And then you actually then work at the real tech, how to really apply it in the world. And you come to the slope of enlightenment, and eventually the plateau of productivity. That's what you all want, because that's where you actually add value to the world, and you actually make money if you're a company. OK, where are we today? Have you all heard of generative AI? Most of you now? Or maybe ChatGPT? Gemini, et cetera. The GPT of ChatGPT stands for Generative Pre-trained Transformer. Yeah? Now, why is that important? Generative models were a step change in that they actually take a lot of data and create a probabilistic model from that. Yeah? What that really means is you can create a lot of relationships between large amounts of data, much like, for example, like language. The other part that's important there is transformer. The transformers were important because it's an AI that can actually parse multiple words at one time, or multiple pages, or multiple chapters even, as opposed to, it used to be one word at a time. And that's why we get the idea of what we call large language models. You can take a lot of data, and you can parse it now very quickly with transformers. Why is this important to you in automation? Because at the moment, generative AI is used for things like text. Now, some of you may have seen sound, images, and video. But actually, soon, it will come to the physical world. What it will mean is you can actually have transformers that work on actions, real physical actions in the real world. And if we do that, we can eventually get to the idea of what we would call a robotic action model. Or a real physical action model out in the real world. Does anybody remember this hype cycle? Internet 2000? Anybody there at that time? OK. What happened in 2001? Crash. Worst crash. Stock market crashed, everything crashed. I was there. I actually had raised money for my first software company. I'm actually a computer scientist originally, and then I became a software entrepreneur, sold 2 companies, and then became a deep tech investor before joining as a VP of X. But in 2000, I raised capital from Europe and from the Valley for my first company, which was the first ever SaaS website building platform. It was called Moonfruit. Some of you who are old may remember that. It was Web 1. Raised a lot of money, but then we hit the dotcom crash. We hit a wall at that point. The venture capital dried up. And so what do? Now, I'm saying this because some of you may be here. Yeah? The thing about hype cycles is people are at different points in that curve. We had to make money what I'd call the old-fashioned way. We actually had to sell a product to a customer who paid money for it. We made a margin, and then we invested it back in the company. Right? Many of you, I'm sure, in automation understand that. Yeah? But we learned the hard way, and we then grew through the slope of enlightenment, raised more capital, actually, scaled. At our peak, we had 7 million websites built on our platform, and then we sold our business. Many other companies do well investing in this trough, because when the hype comes off, you've got to do the real hard work. And good examples of that are Google and Amazon and NVIDIA actually grew through that period, PayPal, etc. OK, maybe let me use another use case. Everybody, automation, you understand Internet of Things, yeah, IoT. OK, this curve came from 2014. So IoT was at its peak hype in 2014. But what's happened since? In the last 10 years, you've seen things like predictive analytics actually become productive. Self-driving. We're obviously from, well, I live now in San Francisco. We really do see Waymos driving around on their own. And it's paid for. And IoT and connected devices are prevalent in society today. Maybe not fully what we want yet in industrial, but most of you now have a mobile phone. It's really an IoT device. I don't know about you, but my children still let me track them on the mobile phone. And we have things like Apple tags now as well. And even our cat has an Apple tag, so we actually track them with an IoT device. So back to generative AI. We're at a peak hype at the moment. I think in robotics, there's a lot of conversation. How many of you in the humanoid conversation the last few days? Anyone went to the humanoid chat? Yep. I think humanoids are now at a peak hype point again as well. And so what does that mean for you trying to apply AI into your real business? Well, if you look at AI that's actually on what we would call the plateau of productivity, things like computer vision, data labeling, cloud services, that's all available today. So you can take that and actually apply that for a real purpose. I was really struck by, a few days ago, there was a panel with our CTO, Brian Gerke, and Stephanie Cannon, who is the Operations Excellence and Collaborative Innovation SVP at Pitney Bowes. She was saying 4 years ago, they didn't really have much more than manual and some basic automation. And now, 4 years in, they have smart, predictive, AI-based automation, which gives them real flexibility. That's very fast, a 4-year cycle. I've been surprised about how slow sometimes adoption happens in the automation industry, but actually that's a very quick cycle. And it's something that at Intrinsic we're really looking a lot at, is how can we use AI to make manufacturing much more flexible, variable, and the idea of being able to have smaller batches that can be produced more quickly and give you that flexibility. I talked about the hype curve. As a business, you do not have to ride up and down that hype curve. It is not fun. I went through that. Yeah? There are ways for you to flatten it. And actually, this is really what we're trying to do at Intrinsic, is help you make use of the AI today, but also stay abreast of what's coming and help you land that, too, in the future. And as a bit of a treat, a little bit later in my talk, our Chief Science Officer, Torsten Kroeger, is actually going to come and show you also some of the future. So maybe it's back to you guys. So if we look at where things are on the curve, let's take CNC machines, for example. Where do you think they are now? Do you think they're in plateau productivity or still in a trough of disillusionment? Anybody? Well, productivity? Yeah, I think so. AMRs? Anybody got a perspective on AMRs? Where do you think it is? Hype? Enlightenment. OK, yeah. So I think they're actually starting to really be used, and people are really knowing how to deliver in the world. And then humanoid. No? Hype, sir, in the front? Yes, OK. Where are we really today? So these technologies do enable productivity today. So robots. A lot of you obviously use robots. Since the 90s, they're 50% cheaper than they used to be. It used to be an industrial robot was more like $50,000. Today, it's less than $25,000. And of course, there are things like cobots coming in that are much cheaper. Hardware devices, plenty of things like CNC machines, milling machines, polishing machines, PLC-based equipment particularly. Huge variety, cost reduction, richer features. And of course, sensors have hugely come down in cost. They've come down from sort of $10,000 a sensor to more like 1,000. Now, what does that mean? It means that things just get cheaper and more feature-rich. You can apply them more into your business. But one thing about having more sensors is you can collect more data. And the advantage of having more data is you can use AI to respond adaptively in real time in your business. And that's kind of really where we are coming in as Intrinsic. We are trying to really look at how to help enable you with that. Now, to do this, you need a much more modern software paradigm for intelligent automation. And an infrastructure that really unlocks the value from the data, the sensors, and now the AI that's coming. So how can we work together, work at actually creating value from that for you? The things we think you need are, you need much more contemporary developer tooling with great, easy user interfaces. Yeah? So a lot more people can use it. You can't always be a robotics AI PhD. Yeah. We think we want to open it up to a much broader group of developers. So people that can use Python, standard scripting, rather than complex languages or modeling. We also think you can use things like digital twins. Digital twins are now getting much better in the physical world, so that you can actually test things out, design things, without actually having to do it physically, which is very expensive if you make a mistake. And the physics is getting better, and so we can really simulate what's going on in the real world. The second thing we think you need is better data management. How can you capture that data? How do you store it? How do you access it better? How do you, though, keep it secure and still private? And we're very lucky to be part of Alphabet in that the Alphabet obviously provides things like Kubernetes and cloud services where that has already been proven and established. I think the other thing we believe you need is real-time control framework, a better real-time control framework, one that can be more interoperable. I think there are real-time control frameworks out there, but they tend to be quite vertical and proprietary. If you really want to enable a lot of automation together, you really need something that's more of a standard. And you also need access to your lower-level controls if you want to add things in like AI. And then the last thing you look at is connectivity. So today, with things like cloud services, we talked about AI. To train large models, you need to do that in the cloud. You can't just do that in your own on-prem area. If you want cloud services, you need to be connected to the cloud. However, we also understand that for most automation companies, being able to have an air-gapped solution that runs on-premise is also important. And so we offer an intermittent framework where we can actually switch between being cloud-connected or being on-prem only. Now what I'm going to show you, and I'm really excited to show you this because the team's worked super hard on this. We have a platform, but we've also built our first product on there called Intrinsic Flow State. And what Intrinsic Flow State allows you to do is to build your own solutions and deploy them onto hardware, physical hardware. So let me show you a bit here. This is a no-code builder of a process. There's a work cell designer that shows in a simulator. The thing about our process builder is each of those processes is a skill that could be as simple as a pick and place, or it could be an AI skill. And so you can actually use that builder to put a set of skills together to run a whole application. Yeah? If you want to, you can also go into our skills scripting tool underneath if you're a developer rather than a no-code focused person. This is actually a cell for assembling a coolant onto a frame. You can see it here running. We're actually calibrating the real world here in the same environment. See that going on? The robot calibration. Now, this is actually running when the actual cell runs in real time, the process runs in real time, and you can actually see a digital twin running in real time too. If you want to see that, if you go to our booth, 2808, you'll actually see that, some of this running with applications in real life. The other thing we're actually doing is we really are building with a much bigger group of developers in mind, not just sort of, again, as I said, robot PhDs. We're actually also building for a community who are called the ROS community. There are 1.3 million developers in there. How many of you know ROS? Yep, most of you. Yep. We're very lucky that actually the ROS, the consulting part of ROS actually joined Intrinsic. We acquired them a year ago, and we're particularly excited that Brian Gerke, one of the co-founders of Open Robotics, actually joined us as our Chief Technology Officer. Brian, I don't know if you want to embarrass you, we'll wave. There's Brian. So you talk to him later if you want to talk to him. Yeah. Yeah, I think so. I think Brian's made a big difference in his team in actually getting people really using robotics in the world. But one of the things we heard about ROS is, and why the ROS team joined is, they also want to democratize access to robotics as much as we do. So we have a mission in mind. What you're seeing here is the RViz simulation tool in ROS. And what we can do is we can take a project there and actually bridge it into Intrinsic. And this was the first stage for us of actually being able to literally bring whole ROS projects potentially into Intrinsic, and then being able to use more of our tooling here and add more of the industrial grade testing, safety, everything else that I think we need when you really want to deploy in larger scale industrial applications. So we're very excited about that. We're going to be developing that bridge over the next year or so. OK, but what's great for you about having new tools like this? You can bring new talent in to building applications. You can actually upgrade the types of jobs that your operators could do, for example. As you've seen, there's a no-code and a basic scripting environment. You could bring your operators up to a level where they could build, effectively, robotic software applications with AI. There are lots of people who are domain experts in process engineers who could also use this to build applications. And they could do that through our tooling and have much greater productivity. Our platform, in effect, manifests what we would say is AI in the physical world. We have a platform on OS. As we said, we have an industrial cloud layer, an industrial edge, and a real-time embedded software set. So really what we're doing with that platform is we can take in things like machine learning in a skill. So perception, computer vision, reinforcement learning. We can also take in things like large language models, generative AI, and eventually, we partner with folk like a lot of the folk like Google DeepMind, for example, who are obviously in pursuit of actual true artificial general intelligence. And I don't think we're there yet, but we're making sure our platform, if needed, can encapsulate that sort of algorithm and skill as it comes down the line. And we want to really produce real applications in industry you can deploy. And we want to make applications more predictable, more reusable, and much more productizable for you. And why is that important for you? Because you can actually, if you can repeat and reuse, you can provide solutions to your customers that create more margin for you too, and more value for them. And as we said, an AI-enabled set of robotics needs an AI-integrated infrastructure. And we really do have an infrastructure that is effectively closed loop. It can take in sensor data. It can use intelligence and algorithms and AI to process that information. It can then send out an action into the world. And then it can actually take that feedback and the response from the world in real time. And I will show you in a second what that can do. This is an application that was built by Robomotion, a hardware robotics provider, and Sotec. And what the Sotec engineer did here was they used flow state to build an application to machine tend an injection molding machine, an Arberg. And effectively what they did was they built this in a couple of hours. It used our remote development tooling on our digital twin, and it also used our collision-free path planning algorithms. And the advantage to them was they were able to train a robot in a very tiny space how to do this task within a couple of hours. And this is literally what the engineer said. It took me several days to program these movements in a conventional way. So seeing this being planned within seconds and running was amazing. Yeah, that's the sort of productivity you can get. This is the more complex cell I showed you earlier with flow state. Now, Kamau, I think, do many of you know Kamau? Kamau's obviously ROAM, but also a systems integrator, based in Italy, but also global. They've been one of our innovation partners now for many years, so 6 years or so. They took a risk on us when we were just a sort of project with a tech breakthrough, but they've been through us through product discovery now, and now into commercial discovery. This is a complex rigid body assembly. So it's a frame where we're assembling a coolant onto the frame, but we're also show a process we can actually disassemble that frame too. It's literally using computer vision, force feedback, motion planning. As I said, it can do assembly and disassembly, but it uses the sense, plan, act closed loop model. When we ran this in Automatica last year, we haven't actually got it here today, but you can see a video of it running. What you can actually do is we actually stopped the process in the middle of it running. We had somebody in the audience come up and actually move the coolant, and the whole process readapted itself in real time. Yeah, so that's the kind of flexibility that AI can bring to your applications in the future. So maybe what tips would I give you if you want to try out some of these more sophisticated applications? I would say, one, pilot with intent. Yeah, know why you're doing a pilot. You've actually got to know what value you're trying to create with the use case. So whether it's an assembly task, you're saving on labor because only human beings can do that assembly task. You know, whether it's about speeding of productivity, whether it's about flexibility of batches, know why you're doing it, understand the value you want, and plan that early with your partner and customer. And the last thing I would say is maybe partner with people if you've got gaps. Yeah, there's a lot changing right now in the automation world. If you're not sure if you can do it yourself, partner up with somebody else and do that too. On that, that's kind of where we are today and how we can help you land AI today. What I'd love to do now is introduce my colleague and Chief Science Officer, Torsten Kroeger, who I think many of you will know, to talk about where we're going in the future. Torsten, thanks.
Thank you, Wendy. All right, good morning. Thank you, Wendy. I now have the great pleasure to talk to you about what we're doing in the context of AI, how we are deploying it through flow state, and how we're rolling it out to our customers and users. Before that, I want to take a step back, and I want to make sure that what I'm going to convey in the next couple of minutes is going to be very concrete, crisp, and clear how AI is really adding value to our customers. Many of you know, and Wendy mentioned that already, Intrinsic is a member of the Alphabet family, so we are a sister company to Google. And therewith, we have the opportunity to collaborate with our colleagues at Google Cloud, Google DeepMind, Google Research. And what we do as Intrinsic, we look for the best research results, put them into our pipeline, and then productize it through flow state so that there's utility value for our customers. The other piece where we believe we benefit from being a member of the Alphabet family is what I like to call the non-sexy topics, like security, privacy, infrastructure, over-the-air updates, monitoring, all of the basic work that needs to be done where many companies, startups maybe in particular, need to develop that from scratch. And we have the opportunity to not start at square one, but actually start with a good boost at the beginning. In order to make this work, we are fully aware that we can't do this alone. It will just not work. I would even say no one really can pull this off alone. And in order to help the industry making a leap forward with the platform thinking in mind, we are partnering with a number of companies. And I would just to highlight 4 examples here. One is Siemens, also well represented here at Automate. And as probably all of you know, Siemens is one of the world-leading companies when it comes to OT technology, if not the world-leading company when it comes to OT technology. Comau has been our really fantastic long-term partner. For many, many years, we have been working in collaboration with Comau. And Comau as a robot vendor, as well as a system integrator, rolling out the first applications together in a partnership. Trumpf, one of the world-leading machine tool vendors, specifically when it comes to the sheet metal industry, is one of our customers and partners rolling out concrete applications actually to their customers. And then the fourth example here, Kiba, one of the prime companies when it comes to robot controllers, edge devices for industrial automation, working together with them as well. Now, what we're also hearing from our customers is that where they want us to start and where they believe AI can add value is in the space of semi-structured environments. So we're not necessarily looking at environments that are static, that are fully structured, where everything can be pre-planned, pretty much automated in a classical way. At the same time, we're also not looking at fully unstructured environments. So we're not envisioning that that flow state can design a system that can work in, let's say, in my home. I don't know about your home, but my home is probably not the right starting point to roll robots out. So we're looking at semi-structured environments, specifically in the space of industrial manufacturing. And the first product that we launched is FlowState. And one of the things that we've implemented in FlowState is a concept that we call skills. And think of a skill as a reusable piece of software. And a skill can be something super simple. I'm going to move the robot from A to B, very traditional, nothing special. Excuse me, nothing special. But at the same time, a skill can also be something more complex, like an insertion skill, or a skill that is fully trained by an AI. And that's what I would like to talk about here today. And there are first-party skills that come with FlowState, but there's also the opportunity for you to implement third-party skills to meet the needs of your application. And I want to, now in the next couple of slides, highlight a few of first- and third-party skills that are fully AI-based. And I would like to start by, and many of you have seen this in the news earlier this week, this is something we announced here at Automate, our partnership with NVIDIA. And I'm seeing Gerard here in the front row as well. So this has been a collaboration that has been going on for some time. And what we have done together is implementing a robot grasp skill. So this is about grasp planning. So think of one of these skills in FlowState as a skill that is purely trained in a data-driven way. And what we've done is we've taken a foundation model from Isaac Manipulator and trained that skill with purely synthetic data coming out of Isaac Sim, took the model, deployed it as a skill in FlowState, and then we rolled it out to a customer of ours. The advantage that we're now getting is that in the digital twin, you can very easily change the robot or change the gripper, change the environment, and you get a lot of flexibility so that this approach is actually very agnostic. So it works across many robots, many grippers, and also many parts that you want to grasp. Now, to show you how this then looks in the real world, I would like to display one application that we have implemented together with our partner Trumpf. And the application here is a sheet metal sorting application. So think of it as a smart pick-and-place application. The robot picks sheet metal parts from one bin and then sorts them neatly in another bin. And all motions here were not programmed manually. There's not a single line of code was written for that. This was all learned by an AI. And if you now want to change anything in the environment, there's, again, no need for coding. All you need to do is you change your model in your digital twin, and this is then what you would get as a result. The second partnership when it comes to AI that I would like to talk about is our partnership, our long-term partnership, I'd like to say. We have been working together for many, many years. Our partners at Google DeepMind. And I'm seeing some of the DeepMind colleagues here in the audience as well. Hi, Akon. And I would like to talk about two things specifically. The first one is about multi-robot motion planning. This is not yet ready to be rolled out, so this is still in our research pipeline. Many of you remember AlphaGo in 2017, where the reinforcement learning framework, the reinforcement learning agent developed by DeepMind, bet the world champion in Go. And as a follow-up, there was AlphaZero and MuZero. And if you now think of how gameplay engines work, it's actually a sort of tree search. If you think about robot motion planning algorithms, what we're doing here is actually Monte Carlo tree search. So we're using these algorithms that were developed for gameplay now for robot motion planning. So we're having a physics simulator, very similar concept to what I presented earlier, a physics simulator generating large amounts of data to find an optimal motion plan, taking into account kinematics and dynamics of all of the robots. And this is now a mock spot welding application. And what we are seeing is that within a couple of hours, you can train a model with, like here, 4 robots. It works with 8 or 10 robots. This is something we have done as well. And the result is, in average, roughly 25% faster than what human engineers do. And we believe that's going to be a huge value add for users of multi-robot systems. In addition, if you now want to change something in your cell, instead of writing code to reprogram things, you can have an AI doing that. And same principle, all you would need to do is change your digital twin. The second example I would like to show here is about dexterous manipulation. This is one of the more complex things, as you can imagine, and Wendy mentioned already the example that we've done together with Comau, where we need visual perception as well as force torque control. Now, this obviously is not an industrial task, but these robots here use the intrinsic framework to be controlled. We use a perception system, we use force torque feedback, and this was actually trained with real data from human teleoperation. And again, same principle, you train a skill, you implement that skill in flow state, and then you can deploy it on your physical robot system. To give you one more example that we believe is a little further out in the future, and this is work entirely done by Google DeepMind, using an application, a use case that was specified by Intrinsic. And many of you have heard and seen the LoA setup. So what you can see here is an assembly application, again using visual perception as well as force torque feedback. And this was now learned entirely with real-world data versus synthetic data, what I mentioned earlier. And there's a human operator here at the bottom that you can't really see on the slide, teleoperating these robots to teach the robots how to execute this assembly task. The last example I would like to talk about today, how we are generating AI-based skills, is an in-house development that we have done at Intrinsic. And this is going to be about visual perception again, specifically foundation models for robot perception. In case you have been at the Intrinsic booth already, you might have seen this. If not, I would encourage you to take a look later today. There's one exhibit where we're showing our perception system. And the way it works today is that the developer of an application uploads a CAD model. Then we train a model in the cloud, download that model that's a pose estimator. And it's a very precise, very robust pose estimator, like sub-pixel accuracy or, depending on your camera setup, sub-millimeter accuracy. But you still have the training time and training cost associated with that. With foundation models, that training time and training cost will basically go down to 0. So it's much faster, much more flexible. And this is what we call then one-shot learning. All you need, again, is the CAD model, but you don't need training time and training cost anymore. And what we've also demonstrated here, and you can see this in this animation here on the left, it works very robustly under all sorts of lighting conditions with very bright lights, like direct sunlight type of light, but also very dark situations. It works with clutter. It's a very robust system, and it works so fast, as you can see here, that we can even use it for tracking. This is not yet part of flow state, but this is something that we're planning to roll out in the immediate future. And with that, I would like to say this is just the beginning. Like there's more coming in the pipeline, and we believe that these new methods to program robots offer a lot more flexibility, a lot more utility value for pretty much everyone who is programming, developing, utilizing industrial robots today. And I'm really, really excited about these opportunities to be part of this adventure that we're all part of. And I would also like to emphasize one more thing again. We can't do this alone. This is an opportunity to work together as a community to enable more and more applications where data-driven approaches are going to play a significant role, and then roll it out at scale in the industry. With that, I would like to wrap up and hand it back to Wendy, who would like to say a few words before we close.
Thank you, Torsten. Thanks. We can't do that without you. That's what Torsten was trying to say. We're part of this community. We're glad you welcomed us in. Thank you to Automate 2024. Thank you to A3, Jeff and team, and all our partners. But I particularly wanted to thank today, actually, the Intrinsic team. So the Intrinsic team that's here, but also the one that's in Munich, in Singapore, in the Bay Area, in Canada, in Zurich. Yeah, thank you to all of you. We all look forward to carry on working with the automation ecosystem and industry. And I think we feel that the world's changing very quickly right now. We'd like to help you land, particularly AI now and AI in the future, but actually make it more accessible to a lot more people. Yeah, and let's do that together. So thank you for having us. We appreciate it. Thank you.